Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore that how we can calculate the amount of VRAM is required to, perform LLM inference. So most of the time, you are not sure that how much of VRAM, the GPU RAM that you need is required, to run or inference a large language model. So for example, if you talk about Llama 3.18b model, how much of GPU I need? Do I need, or if I have a single GPU, how much of VRAM, which is video random access memory, is required to inference? So I'm going to show you a basic calculation and different tools that you can use to make an estimation, of the VRAM is required for both inference and sometimes training as well. So let's jump in and see how we can do that. Now, we have to understand how do LLMs basically use VRAM. Okay, so let me just write it over here. So I'm just writing VRAM and that for video random access memory. Now, it's a special type of memory, guys, that used in GPUs. Uh, Almost 25 years old. They were invented in late 90s, 1990s. For image and graphics rendering. So this basically for uh, high computations. So high computations mainly for accelerated compute. That's why it's required, for image and mostly the graphics rendering, to deal with the graphics rendering things. Uh, the purpose, it doesn't. So it's very evident that we also have CPU's memory. We have CPU and we have memories, but we cannot exactly use it, and I'll tell you why. When it comes to get a better performance when we are inferencing large language models, the purpose of these VRAMs was to offload, uh, you know, the tasks like image or graphics rendering or anything from CPU for efficient and faster, rendering of. If you talk about image, then complex visual scenes, because if you have played some game, you will understand the games like FIFA and all where they have high quality visuals that they have, right? Now, and that's where it came in. So it basically offers a high bandwidth compared to the standard system RAM that we have, and it allows faster data transfer. So you should keep this in mind. That's the main thing. So I'm just writing faster data transfer. Faster data transfer between the GPUs. So if you have multiple GPUs as well, or if you have a single GPU and its memory. So GPU and its memory, so the data transfer will be faster, which enables processing large amounts of graphical data. And nowadays, different formats of data that we are dealing with. So that's how it started, guys. And we're gonna, you know, see how we're gonna calculate it, a few things. So if you talk about why it is important, let me just write it over here for you so you can see it. Maybe we can make it bigger. Okay, so how do LLMs use VRAM? So that's the question now here. Okay, so let's just how do LLMs use VRAM? That's the thing. First is talk about model parameters. So let me just write it over here. Model params. Second is your activations. And third, batch size. And then four is your precision. These four are the important topics or categories when you categorize the use of VRAM when you make an LLM inference. So inference is a very fancy word, to basically generate something out of an LLM. Okay, basically we're running an LLM to do a next token prediction or chat or instructions, whatever. Now, in model parameter, what happened? You have millions and billions of params, and now trillions as well. So millions and billions of params that you have. Now, these are stored in VRAM during the inference. So basically, we store them. So storage. Now, in the activations, what happened? Each layer of an LLM generates substantial amount of activation data, which is temporarily stored in a VRAM. So basically, you do a temporary storage of, all the activation data that you have. So temporary storage of activation data. And then you have batch size, which is pretty much self-explanatory. So if you have a larger batch size, more VRAM is required because then the model has to handle, uh, a very large batch size having inputs, and they do it simultaneously. So it's a, uh, it's you would have seen this in deep learning as well when you used to work with neural networks earlier. So in the batch size, what we see, if you have a larger batch size, then more VRAM. Okay, so it depends what kind of GPU you have. Precision, basically the floating point. How do you want to how do you want to use it? So there are different. So you have FP16, floating point 16, 32, int 8-bit, int 4-bit, blah blah blah. So you have different things over here that you can look at. So this is how the VRAMs are distributed. So it starts from model params, activations, batch size, and precision. So that's how it works. Now the formula that we see is pretty much if you talk about a simple formula, it is number of params, and then you multiply this with precision, and this precision is divided by 8, and then you just multiply all with 1.2. Now this 1.2 is nothing but the 20% that we are, and there are some assumptions of it, and I'll show you the different tools that you can. You probably don't have to you know use this formula because there are a lot of tools that you can use it. 20% activations and other things like other memory that you have in the process of inference. Now, number of parents. So, for example, if you want to talk about Mistral, let's talk about Mistral 7B or any model. Now, if you talk about Mistral 7B, the number of params becomes 7 billion. So it has 7, and it always has to be in billion if you talk about this formula. So 7, and then imagine if I'm loading the model, or I'm going to use in FP16. So if I have 16 floating point as a precision, and then I multiply all with 1.2. So this total become, I don't know how, right? It becomes 2 and 1.2, it becomes 14, 1.2. So basically you need around 16.8 GB of VRAM. 16.8 GB of VRAM is required if you look at this formula. Now, there are some assumptions. The assumption is max sequence. So max sequence is 512 for this assumption. So you have max sequence 512, then you have batch size, which is 8, and GPU is 1. Only one GPU are talking. You can have multiple GPU, and then you can offload and distribute. You can do a uh, parallelism over there when it talks about different GPUs that you have. Now, this is a pretty simple and straightforward formula. Nowadays, we have better optimization techniques. There are a lot of frameworks or libraries that you have, starting from Unsloth, VLLM, blah, 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 based on paged attention, rope scaling, and whatnot. So there are different techniques that you can use to basically optimize the need of VRAM, in an LLM inference. Now, but this is how a very simple one works. Now, I'll show you different tools that you can use. And I'll give all those link in description. So you see this, let me just refresh this. We have different tools. One is called VRAM estimator. It says estimate GPU VRAM uses of transformer-based model. So I'm going to focus more on transformer-based model, only talking about open source and transformer-based model. Now, here you can see it says inference and training. So if I click on inference, running params, then you have FP16, BF16, FP32. So for example, if whatever is default, let's select that FP16, max sequence length 512, batch size, if I increase that to 8, number of GPU 1, and if I select a model from here, you can see, you can find out some model. And if you see, and these are, you can again, you can change the, you can see here what it says. It says Model parameters could be taken from config.json on Hugging Face or directly from model via model.config. Now, if I select, for example, if you want to do Mistral 7B, okay, in this case, you can see number of params, number of layers, vocabulary size, hidden size, blah, blah, blah. So these are the, if I make this in GB, as you can see very close, as we said, 16.8 GB of VRAM. Here you can see 16.219 GB of total VRAM. And it also shows you that how much of is distributed. You can see the CUDA kernels. You can look at the parameters and look at the activations and outputs. So mainly the distribution is on parameters. So it gives you a distribution that how these have been calculated. So if we talk about the parameters used, number of parameters is 7.51 billion, then it multiplies that with number of bytes per parameter. So number of bytes per, so 2 bytes per parameter, you can see it over here, then it becomes 13 point, almost 14 GB of VRAM, and then some activations, and then output tensors. Okay, and then CUDA kernel over here. So you can use this tool. You can also use it for training if you want. It gives you how you want to train it on mixed precision. If you want to use an optimizer, for example, Adam optimizer, and keep this, and for example, this looks good. To hold on for a second. Total VRAM is 152, first moment, second moments. Now, if I'll just make batch size 2, if you change the batch size over here, if you look at here, if you, when you made it 2, it drastically reduced the GPU need. Number of layers 32. Okay, if you do it on these configurations of model parameters, if you do it on full, if you do on SGD, stochastic, you can find out the change in the GPU VRAM over here. So you can use this tool if you want. I'll give this link in description. The other tool that you can use, which is by HF Accelerate, Hugging Face Accelerate, that's called Model Memory Calculator. Now, using this tool, you can calculate. So, for example, if I just want to show you something here, so you change model name or URL. So, if, for example, if you want to use Whisper, an open source model by OpenAI for speech to text tasks, now you can select transformers, and if this is fine, and you can see the need of this. So basically it shows you the memory uses for OpenAI Whisper Large V3 and training also using Adam. So it also explains that below. Now here it shows the memory uses. You can find out all the details that you need. The D type, the largest layer, which is whatever is there in the model, the total size, and training using Adam, blah blah blah. You can also use model memory calculator to also test it out. You can also use this. Can you run it? LLM version. You can find this is a bit more comprehensive and based on Eleuther AI Transformer. If you guys don't know, I will recommend you read this Transformer Math 101. This is a fantastic blog written on Eleuther AI. It's very old. It's like almost more than a year old, and you can read that. Now you can find out. You can also use this tool. Pretty much straightforward. You can bring up your own model here. If the model is sitting beside behind a gated repo, or then you have to bring up your access token. You have to change your model name. You have your GPU vendor over here, and then you have how many like which GPU you have, A10, A100, blah blah blah. So you can also use this bit more comprehensive. This is the simplest one that you have, and this is where you can read it, and you can also use this. This is what I wanted to do in this video, guys. I wanted to show you that how you can calculate the amount of VRAM is required, GPU is required to do LLM inference. And there are other tools as well, but these are the tools that I refer to, and I'll give all of these links in description. If you know any other tools, please comment it down for our audience, guys. That will be beneficial for us. That's all for this video, guys. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. That motivates me to create more such videos in near future. Thank you so much for watching. See you in the next one.